Hello, my name is Mahar Al Asfar, and I am a product marketing engineer within the VMware Cloud Foundation division at Broadcom. In this video series, we will demo the VCF private cloud experience, where ACME Corp needs to test and deploy a new customer portal application for their sales team. In part 3 of this video series, the consumer, which includes the end user and application teams, can deploy all applications built on top of containers and virtual machines using the same methodologies. So let's get started. On our slide, which is acting as our demo launchpad, we're going to go ahead and click on consumer. This is where the developer or the application team is going to deploy the customer portal application first using the IaaS services into development, which is the development namespace. And then later, we're going to use the catalog items or services to deploy the same application in production. So we'll click on consumer, and we're going to be at the login VCF automation page where we're going to provide our organization name. We know that's ACME Sales. And I'm going to hit continue. Notice that here the org admin have already set up the identity provider for us for this org and connected it to LDAP. So now Mary can, for example, use her Active Directory credentials and be able to log in here into the org. So Mary is an advanced user in the customer portal project within the ACME sales organization. So she has access to that project. So we can see one there, and has access to the two namespaces in the project that we've created before. And that is the development namespace and the production namespace. This is the namespace selector and is set to development. So when I'm clicking on the service overview to go and access all the core services, we are still in the development context. This is our destination for anything that we're going to deploy going forward. So we're going to start with the virtual machine service. For our application, it has a backend MySQL database that's running on a virtual machine. And then it has two application tiers that's going to run as Kubernetes deployments, meaning containers on a VKS cluster. So we'll start with the backend database, and we're going to go to the virtual machine service. And here we can see a list of available virtual machines that was provisioned before, which is obviously there is none. And also we can here we can deploy and manage VMs in a self-service way using Kubernetes API. So I'm going to go ahead and click on Create VM to access the new virtual machine workflow. Starting with, we have to pick the source type. So we can choose between OVF and ISO types. OVF have a lot more options for us, especially advanced options that we need for our MySQL application. And then we have the ISO. So we're going to keep it at OVF here and click next, and then provide the name of the machine. So I'm going to call it MySQL Dev Database -DB. And then we have to make a decision on if we want to leave the zone automatic or use or explicitly select a zone. If you leave this to automatic, basically the zone is going to be automatically selected for you. One caveat here is that the storage volumes you will not be able to attach new storage volumes to the VM. To do that, you have to use the actual zone. So storage volumes can be attached, which we want to do in this workflow. Then I have the list of the VM images that is available to the development namespace based on the namespace class, if we remember from the last video when we created a namespace. So these are the images available to this namespace. So I'm going to select Ubuntu 24. And then the VM class is our virtual hardware specification of the virtual machine that we're providing, or t-shirt sizing. I'm going to select best effort small, and remember that best effort meaning there's no reservations when it comes to CPU. Now, before I move on to the next step, notice that everything I've selected has been updated in the Kubernetes resource YAML on the right-hand side. So we can see on line number 4, the name that we provided, the namespace that we're targeting on line 5, and also the class name or the t-shirt sizing on line 10 for the VM size we want. and the image name. Of course, here we're seeing the image identifier, unique identifier, VMI, but we also on line 11, we're kind of pointing out, oh, by the way, this is this VMI, and here is the friendly image name for it. Just to enhance the user experience and let the user know what OS, to continue letting him know what OS they've selected. The storage class, you have the option here to select the storage class, but we only have one. And of course, the power state, we want the VM to be powered on. You can hit review and confirm if you do not need any more advanced settings, but in our case, we do. So we hit next to access those advanced settings. The first thing I want to do is really specify additional disk volumes. I can attach a volume, and this volume is going to be, I'm going to select the storage class, which is, again, the only storage class available to me. And then I'm going to provide 5 gigabyte. Now, there is an option here. If this volume has been already created by a previous user, I can choose from an existing volumes. And this is great when you are working with databases where the database is already stored. So these existing volumes have their own internal life cycle. So when you delete the VM, you really don't have to delete the volume, and you can leave the volume for the next VM if you decide to provision a new one. I'm going to hit save and move on to the load balancer. So the VM can be exposed as a load balancer, and you can also opt to select an existing load balancer or create a new one. We're going to go ahead and create a new one, and we're going to create the first port on this load balancer to be able to SSH into the VM on port 22. And also, I'm going to do another port for the MySQL port, which is 3306. And I'm going to add those as 2 targets, and I'm going to hit save. Notice when we created the load balancer, on the right-hand side, we've created another YAML file for the load balancer representing the virtual machine service kind or object kind. We can see that on line 2, and then we have the specification, the ports, and the protocols that we chose to open. On the guest customization, we support multiple bootstraps. The guest customization allow you to specify any data, configuration, or scripts that you want to run on the VM when the VM starts, or when which is used to really initialize the VM with whatever applications or commands you want to execute when the VM is bootstrapped. You can choose from Cloud Init, sysprep, Linux prep, and VApp config. I think the 2 most common ones that user would really lean towards is always going to be Cloud Init for Linux and sysprep for Windows. The Linux prep and the VApp config, these are very much VMware focused and only for, of course, virtual machines running on vSphere. So we're going to use Cloud Init. There is a guided input that we will not be using here, but this is really helpful for customers who are not familiar with Cloud Init, where they can go and provide their time zone, select if they want to enable a default user. Let's say they want to create a user and enable him for admin access. So they're enabled for to be a part of the sudo group, and then run any commands you want. But our configuration is a little bit complex, so I'm going to just use the raw configuration and put my cloud config code in here, which going to automatically create a bootstrap secret object and pass these packages and commands and the users I want to create all in a secret object. So once I'm ready, I'm going to hit next. And then we have the option to add up to 10 different network interfaces. And there's already one been added, but we're going to make sure that it's on the right subnet. And instead of being it on the private, for example, I'm going to opt to select the public subnet that was created within the VPC within our org. And this is basically within the VPC that this namespace has been provisioned from. And remember, when we provisioned a namespace, in the previous video, we chose what VPC to use, which is going to define our network boundaries. We're going to leave the global network settings. These are global network settings for all the network interfaces that you're going to add here. And if it happens that the host name is going to be different from the VM name, you can go ahead and provide the host name here. But as long as you don't provide it here, it's going to use the same name that we provided initially for the VM. I'm going to hit next. And now, and before I can deploy, I can go and I'll download all the YAML files that we see here. We have 4 different YAML files, one for the virtual machine, one for the secret, one for the load balancer, and one for the persistent volume claim for the attached volume that we've added. All right, so ready to go and click deploy. This is going to deploy our application. Once the VM is up and ready, it's going to have an IP. It's going to be powered on. You're going to see what image it was provisioned from and what VM class it was configured as here, which is using best effort small. If we click on the VM, we can see additional details and labels, for example, including the age of how long the VM has been up and running, as well as access to the remote console or the web console if you want to access the VM. And if we go to the overview, we can see the counters on the virtual machine service and the network service has been added to 1. And now we're ready to go and provision our VKS Kubernetes cluster so we can install the application backend tier and front tier on the VKS cluster, which is our Kubernetes cluster. So just similar to the virtual machine, I'm going to click go to service, and I'm going to see a list of Kubernetes service or VKS clusters. Obviously, there's nothing right now, and we're going to create our first Kubernetes cluster. You have this cluster type, which will allow you to support the new cluster class or cluster API, which is going to be going forward. And then the Tanzu Kubernetes Cluster API is there for backward compatibility. We're going to keep it on the cluster API. And because we want to use custom configuration, we're going to click on custom configuration, and that's going to give us more options to go through. Things like being able to set the cluster name. We'll call this cluster Portal Dev Cluster 01 since we're in the development namespace. And also, just like the virtual machine service, we have a Kubernetes resource YAML that's going to get generated based on our selections. We can select between or from different Kubernetes supported releases. I'm going to just keep it on the latest at the time of this recording, 1.32.0. And well, there's a lot more advanced options really available to the requester, like attaching volumes, attaching labels and selectors, doing taints. But really the most important one I like to highlight here is the certificate rotation. So the default is 90 days. We're going to go ahead and increase that to 180 days. And then you have the option to also use a proxy if you need internet access, if this is like a dark site or you can only get to the internet through a proxy. You have the option to provide your HTTP or HTTPS proxy. And then for the network, for our pod CIDR or services CIDR subnets, you have the options to change those if they overlap somewhat with your network. But I'm going to keep it here as default. And then we have persistent volume storage for this VKS cluster. You can leave this not selected, but if you have multiple classes and you really want to pick only one of them and not all of them, you can always add the storage class you're intending to use and set it as your default storage class. And I'm going to hit next. Now we get to the control plane. This is where we can select how many replicas of control plane we want for our VKS cluster. The VM class, the t-shirt sizing, very much similar to the VM. We're going to select best effort small. We're going to keep the replica to 1. And I'm going to hit next. To go to the worker nodes, or what we call the node pool. Node pool, you can create one or more node pools, and these are a group of worker nodes. So I only need one for now for this demo. I'm going to select 2 replicas for my worker nodes, and I'm going to keep it on best effort small, just like the control plane VMs. I'm going to hit next and keep everything as default. Now we're ready to move on and review and confirm. Again, just like the virtual machine service, the Kubernetes service, I can go in and download the YAML manifest that got generated based on my inputs. But we're ready to go here and hit finish. And once our Kubernetes is up and running, we're going to see a state. Initially, it's going to be false until the Kubernetes cluster is fully deployed. And then we have a ready state, which is indicated here with the green check mark as true. So our Kubernetes cluster is up and running, and we can click into it, or the double arrows, and have and look at additional information, and also be able to download the kubeconfig file here if we want to interact with this VKS cluster automatically. So now our VKS cluster is up and running. We can basically see on the overview that now we have 4 virtual machines instead of 1. Remember, we've installed 1 control plane replica and 2 worker nodes. So it gets the total to 4 virtual machines. We have 1 Kubernetes cluster and 2 network services. If we do go and see the network services that we have, we see the load balancer from the MySQL VM here with the external IP to access it, the load balancer. And then we see the Kubernetes API server of the VKS cluster that we've deployed and its external IP address on port 6443. If we go back to the overview here, and now we're ready to install the application manually on the VKS cluster. For that to happen, Mary has to generate a token. So we can go to the username on the right upper left corner and click on My Account. Click on API token and generate a token for our user Mary, and copy this token. We will use this token as our refresh token to use it from the command line, so we can get granted access to the cluster. Now that we have the token saved, we can switch to our command line and create a context. So the first thing here, assuming that you've already downloaded the VCF executable, the VCF executable can be downloaded from various locations. One of them is really the standard package managers like apt and yum and chocolatey and homebrew if you're on Mac. So here we have already the VCF downloaded, and we're ready to create a context. We're going to create the context and name it after the org, ACME Sales. Provide the input that we're pointing to, which is our FQDN of the VCF automation appliance, and then pass the API token that we just generated and provide the tenant name that we're a member of, which is the org name, ACME Sales. We have the certificate. So we make sure that connection is secure. So we're passing also the CS certificate of the VCFA appliance. Once the context is created, it's going to refresh and download all the needed plugins. You can see we're successfully logged into the VCF automation appliance. And based on our project membership, we have now access to the following context. The base context is the org ACME Sales, and then the 2 namespaces that we have under the customer portal. You can see the syntax starts with the name of the context, which we named after the org, or best practices. You can give it any name you want. And then the second, after the hyphen, the second is the namespace destination, and then part of the project, which is customer portal. Now, next, we need to change the context. So any commands we execute, it's going to execute against that namespace. So we're going to say VCF context, use the context name, which is ACME Sales Development Customer Portal in that order. And that's going to put us into that context. Because this is the first time we're switching context to a namespace, it automatically installs the recommended plugin. And you can see that we've installed a cluster plugin, a Kubernetes release plugin, a namespace plugin, package plugin, registry secret plugin, and a VM plugin. All these plugins are part of that VCF framework. So it's a pluggable framework that allow us to use the VCF command line against those services, or using those plugins to interact with the services. Next, we're going to, now that we have access to these contexts, we can list them with VCF context list. So you can see that after we used the VCF use context, the VCF context use command, we see that we are currently on the development namespace, and that's set to true. So now if I try to do a traditional kubectl get VM, within a wide output. We can see the virtual machines that we saw in the UI earlier. We see the SQL VM. We see the VMs of the Portal Dev cluster that we also provisioned. Also, if we do kubectl get service, we see the two services that we also saw in the UI. One being the load balancer for the MySQL VM. We can see that we're enabling port 22, which is SSH, and 3306, which is MySQL. And then we see the Kube API server of the VKS cluster that we've also provisioned, and their external IPs. If we use the kubectl get cluster, we can see the cluster and the phase it's in, and we can see it's provisioned. Now, this is one way of doing this, but if you want to use the plugin framework, we can use VCF cluster kubeconfig and then pass the name of the cluster so we can get the kubeconfig file for us. So VCF cluster kubeconfig, and go and get that kubeconfig for this cluster. It's going to tell me, well, you can access this cluster if you run this context, and it provides the context that I need to run. So I'm going to copy that and paste it into the command line. So now any commands I'm going to execute, since my context is the VKS cluster context now, if I do something like kubectl get nodes, it's going to ask me for the first time to provide my API token, which I'm going to do, and then it's going to execute the command and make that interaction with the cluster and list members of the cluster. So we see we have one control plane node and two worker nodes. Now we're ready to deploy our applications. Since we have that interaction on our VKS cluster and we're in the right context, we're going to create a namespace to group all the components of our application. So we're going to name that namespace customer portal. Now that we've created the namespace, we can go and start executing our YAML files. We'll start for the application backend. So it's a two-tier application. It's a three-tier application, but two of those tiers are running on the Kubernetes cluster, and the last tier, which is the database, running on the VM. So I'm going to grab my YAML, execute that, and I'm doing kubectl. So this YAML and its components gets installed into the customer portal namespace that I just created. This namespace is on the VKS cluster, and not to be confused with the supervisor namespace where this VKS cluster is actually provisioned in. So you can see we've deployed three components. This YAML file has three sections, one for secret, one for the deployment, and one for the service. And then if we go and say get all customer portal, we can see that our pods and deployments are up and running. And we also have a service IP automatically for the backend app service, which we will use for the front end. So now we're ready to do the front end side of the application, which is the web tier. Again, we're deploying the YAML file into that namespace. It's going to create also three objects, the secret, the deployment, and the service for the front end. And if we get all, we now see both tiers of components listed for us, both the front end app and the backend app components all up and running. And if we close this and go back to the UI and go to the service, you can see our services got updated now, and one of the services that we're seeing here of type load balancer has the external IP of the application. So if we grab that and go to this IP address, we see our application loading successfully, and this is the application that we just deployed. Now, if we switch, all these manual things that Mary have done to deploy this application can be grouped together in a blueprint. So we're going to do this. The org admin or the project admin have already created a blueprint that basically captures all the steps that Mary did manually. We're going to switch from the development to the production namespace. And as you can see, we have zero resources here. We have zero virtual machines, zero Kubernetes cluster. And now we can go to the catalog, and we already have a customer portal application. This is a blueprint that was built to create all these components manually and install the application. And it's available for Mary to install. She can go through the custom portal and provide the deployment name. This is going to be our production customer portal application. We have the option to actually deploy this to both namespaces if that's how the blueprint was authored. But we want to deploy this to production now that we know the application is successful. And then on the MySQL database side, we're going to provide the MySQL virtual machine name, the image. It's going to be Ubuntu 24. The size, I'm going to opt here to use medium because we're doing this in production. And then the subnet is going to be on the public subnet. You also have the option to execute the external extensibility. So I want to leverage memory tiering on VCF9 for my database. So it's going to make sure that the VM is deployed on a cluster where memory tiering is supported. And then for the web front end, we're going to pass the cluster name. And this is going to be Portal Production Cluster 01. And then the size of the size is going to be medium of the cluster. And then I'm ready to deploy this application. So everything we did manually, as we saw Mary do from the command line to install this application, is automatically being done here. It's provisioning the backend virtual machine, it's provisioning the VKS cluster, and then it's installing the backend tier and the web front tier deployment on the VKS cluster. If we click on the deployment, we can see the topology of the application. We can select any component and execute day 2 actions on them if we want to. But we're going to close this and then switch over to Kubernetes, and we can see our Kubernetes cluster for production. Remember, we're in the production namespace based on our selector here, and we're looking at our production portal cluster 01. If I click on it, I have access to all the information here. I can add additional volumes if I want to. Also, with the VCF operation integration, I can monitor and look at basic metrics on the cluster level, on the namespace level, and the node level if I want to. And I'm looking at things like CPU contention and utilization, memory contention and utilization, and then network contention and availability. If you want to focus on our application, we can select our customer portal namespace and then get those data points and metrics on the namespace level or on the deployment level itself. We go back to the overview and go back to the services. We see our services for the based on the catalog that we requested, and we see our external IP application for our production side of the house, and we can see our application is deployed. If we click finally on the overview page, Mary can see the top utilization within the org, and now she can see that the customer portal has 2.7 gigahertz has been used for CPU, 40 gig of memory has been used for memory. And also if we switch to the namespace or filter by namespace, we see both namespaces and we can compare the utilization, and we can see that the production CPU memory and storage is a lot higher because we've basically deployed higher VM classes or t-shirt sizing when it came to the size of the MySQL VM and the size of the cluster nodes. With that, using VMware Cloud Foundation, ACME Corp can build a private cloud while abstracting the underlying backend services. This provided a seamless and uniform way to consume and deploy infrastructure and application across the entire VCF Cloud Foundation fleet, ensuring efficiency and ease of use. That wraps up this video. We hope this walkthrough helped clarify the VCF private cloud experience and gave you the necessary tools to move forward. Until next time, thank you for watching.